Multi-objective optimization in drilling of GFRP composites by using the application of artificial bee colony, ABC, algorithm. Abstract: the purpose of this work is to evaluate the best optimum values for glass fiber reinforced plastics, GFRP, using artificial bee colony algorithm, ABC. Composites are made by using glass fiber and epoxy resin to form GFRP. Based on the drilling of GFRP, the input characteristics are greatly influenced, such as feed, drill speed, and drill diameter, by various process parameters, generally torque, thrust force, delamination factors, both entry and exit, and surface roughness are considered as output performance characteristics in composite drilling. The influence of input and output parameters is obtained to determine the best optimized values by means of ABC algorithm. Keywords: glass fiber reinforced polymer, GFRP, artificial bee colony algorithm, ABC. Introduction. Drilling process is incredibly utilized for creating riveted and bolted joints during assembly operation of composites with other components. Glass fiber reinforced plastic, GFRP, composite are mostly used in large areas. They were used in industrial fields such as aerospace, aircraft, electrical appliances, automobiles, and sports goods due to their properties such as high specific strength, high specific modulus of elasticity, lightweight, and corrosion resistance. The nature of cutting hole in a glass fiber reinforced plastics, GFRP, is effectively dependent on the appropriate decision of cutting parameters, primarily torque and thrust force expanded with feed rate and drill diameter because of increase in SR and shear area. Delamination factor is strongly in need on cutting parameters, tool geometry, and feed in drilling of composites. A algorithm is a program intended to play out a particular assignment. This can be utilized for both straightforward and complex capacities, for example, duplicating the two numbers, entangled capacities like building up an activity in PC programming and it has an exceptional activity like change the convoluted work into basic work and furthermore done a particular undertaking. An extensive overview of all the different processes needed for composite materials parts manufacturing in current research fields and partly in current industrial applications is given in 1. The best arrangement for executing strands during added substance fabricating while picking between the named ideas and glass and carbon fibers, is immediate overprint with glass fibers. 2. To make contemporary composite manufacturing and address the advanced composite additive manufacturing. 3. Dissect the innovation of fiber fortified polymers and executed with added substance fabricating with this innovation. 4. The mock-in ability can be achieved by conventional machining process such as turning, drilling, and this work grant the main issue. It found that low mock-in ability for FPR composite material to overcome this problem for conventional machining is far better than that. 5. The carbon and glass fiber composite materials are used under the procedure towards penetrating and processing, fundamentally to pick the workpiece quality and planning time. 6. The comparison among regular and orbital drilling to cut unidirectional CFRP material with diamond-covered tools, and it principally analyzes where it produce bore diameter changes, workpiece harms, tool wear just as process duration. 7. The utility of PSO and ABC algorithms to describe turning operations of CFRP composites and optimization of drilling process parameter has been studied for the Harmony algorithm. 8,9. SR and GFRP were enhanced by expanding cutting speed and the machining parameters like torque and thrust are incorporated with feed, cutting velocity, and drill size. 10. The delamination consider under various cutting conditions and it additionally featured to set up the connection between feed rate, drill width, and axle speed with the incited delamination in a CFRP. 11. The analyze of the tool life during the machining of composite materials under the machining parameters of drill diameter, feed and speed and to clearing up the crack or the failure system. 12. The progression of drilling parameters with execution in dim relational thought. It incorporates parameters like shaft speed, feed rate with executing the characteristics of push power, surface unpleasantness and delamination factor. 13. The turning operations in GFRP is proposed with the fuzzy interference system with Taguchi approach to achieve optimal machining conditions. 14. The GFRP was drilled and all the parameters were examined and the optimal Conditions found out by utilizing Taguchi and response surface methodology. 15. A. Objective. To discover the optimum value for glass fiber reinforced plastics, GFRP, should be possible utilizing artificial bee colony, ABC, algorithm. From the input parameters like speed, diameter, and feed to gain output parameters like torque, delamination factor, thrust and SR using for the purpose of finding the optimum values. 2. Experimentation. Glass fiber is fundamentally a common type of fiber reinforced plastics, and it is cheaper and flexible than any other fiber. It is most commonly used in the application of tanks, aircraft, roofing, pipes and boats. Here epoxy resin Li556 and hardener is added to make a GFRP Composites epoxy resin have high strength and excellent environmental resistance. The pattern is prepared with a 15x 10 mm rectangular plate to make GFRP material. Composition and preparation of GFRP are 70:30, glass fiber, resin plus hardener, 500 g of glass fiber with 150 g of resin and hardener. After the preparation of GFRP, it is pressed with the help of compression molding to get high-strength glass fiber material. Hereafter the GFRP plate has been drilled using vertical milling center, VMC, with that drill tool dynamometer has been attached to find out thrust, torque. Taguchi orthogonal array, L27, method are used for designing the experiments, and 6 mm, 8 mm and 10 mm drill bits are used for drill the composites. Feed, diameter and speed are given as an input and output such as thrust, SR, delamination factor and torque, calculated from readings taken from drill tool dynamometer, and SR tester readings are given as an input to artificial bee colony, ABC, algorithm to get the best optimal machining parameters. 3. Artificial bee colony algorithm. ABCA is attracted by the foraging behavior of honeybees. It follows a collective intelligent manner while searching the food. It has many qualities like communicate with other bees, sharing the information, store and take decisions based on that. The behavior of real honeybees can be precise in the head's name, food sources, employed and unemployed bees. Here, SR, torque, delamination factor and thrust force are considered as a honey. To select the best optimal parameters from the given parameters, Topsis method is used. It convert multi-objective variables into single objective variable. The single objective variable are considered as best optimal values. It shows the behavior of honeybees by selecting the particular and best machining parameters. A flowchart for ABC algorithm. Determining the coefficient. Determining upper and lower limit. Enter number of sample particles. Enter number of iteration. Initialization. Evaluation. Multi-objective to single objective using Topsis. Selecting the best one and store it in variable. Display. Selection of the best bees. Calculation of new employed bees. Unemployed bees. Reinitialization. Be observing graphs from ABC algorithm. Fig 4 graph comparison of given readings. This graph shows that comparisons of thrust force, torque, SR, RA, delamination factor, FDIN, FDOUT, with the help of number of iterations, sample, as we compared the results, minimum values of torque, thrust force, SR, delamination factor are considered as a best optimal values or best optimal machining parameters. The first graph shows the connection between surface harshness and number of tests. It shows the minimal increment of surface unpleasantness when it moves to most extreme examples, and next chart shows the connection among speed and number of tests. It shows the steady change in speed, and next chart shows the connection among push and number of tests. The current diagram shows slow diminishing in push as indicated by increment in tests. Last diagram shows the connection among torque and number of tests. It shows the abrupt abatement in torque toward the finish of the examples. For results and conclusion. In the current examination, dependent on the information investigation and exploratory outcomes, the accompanying ends can be drawn. The approach is utilized to change over the multi-reactions, push, torque, delamination factor, both section and exit, and surface harshness into a solitary reaction. Presently the ideal mixes of procedure parameters acquired from the artificial bee colony algorithm. Optimal combinations of process parameters are: in the experimental result, the maximum thrust force obtained is 0.21 for the combination of speed 2700 rpm, feed rate 350, drill diameter is 6 mm and the minimum thrust force obtained is 0.016 for the combination of speed 1800 rpm, feed rate 300, drill diameter is 6 mm. The maximum torque obtained is 0.96 for the combination of speed 1800 rpm, feed rate 300, drill diameter is 6 mm and the minimum torque obtained is 0.062 for the combination of speed 2700 rpm, feed rate 300, drill diameter is 10 mm. The maximum SR obtained is 4.81 for the combination of speed 1000 rpm, feed rate 250, drill diameter 6 mm and the minimum SR obtained is 2.34 for the combination of speed 2700 rpm, feed rate 350, drill diameter 10 mm. The maximum delamination factor at the entry obtained is 1.4749 for the combination of speed 1800 rpm, feed rate 300, drill diameter 10 mm and the minimum delamination factor at the entry obtained is 1.4683 for the combination of speed 1000 rpm, feed rate. The maximum delamination factor at the exit obtained is 1.4912 for the combination of speed 2700 rpm, feed rate 300, drill diameter 10 mm and the minimum delamination factor at the exit obtained is 1.3728 for the combination of speed 1800 rpm, feed rate 300, drill diameter 6 mm. Based on the ABC algorithm, the best optimized value, thrust 0.01678, torque 0.06158, SR 2.349, delamination factor fin 1.4683 and FOUT 1.4974, obtained by the range of 2600 rpm speed and 250 mm per minute feed rate for 8 mm drill. And the values achieved from the algorithm are again experimented. From that experiment the values are thrust 0.01782, torque 0.06481, SR 2.458, delamination factor fin 1.4723 and FOUT -1.5147. The both experimental and algorithm values are similar, therefore the best optimal values are gotten from this experiment for better machining.